For 2 years, the AI industry operated under one dominant assumption: raw reasoning power would solve every enterprise problem. That assumption has shattered. Frontier models possess immense intelligence, yet they continue to fail in production environments. Intelligence is no longer the bottleneck. Execution is. These highly capable agents do not fail because they lack knowledge. They fail because they confidently make incorrect assumptions. When deployed across complex, multi-step workflows, a single hallucinated premise early in the chain silently corrupts every subsequent action. This reality defined the transition visible across the enterprise landscape in June 2026. The market exhausted the utility of isolated, experimental chatbot tools and began demanding disciplined, coordinated infrastructure. To make AI function securely at scale, engineers are rebuilding the architecture. They are abandoning monolithic chatbots in favor of systems built on operational reliability, dynamic multi-agent workflows, and mandatory runtime governance. This forces a complete shift in evaluation. Engineers are no longer asking, "How smart is this model?" They are asking, "How reliably can this system be orchestrated across an extended workflow?" A model capable of scoring perfectly on a reasoning benchmark holds zero enterprise value if it cannot be trusted to execute a complex task end-to-end without human intervention. Anthropic designed Claude Opus 4.8 specifically for this new reality. They bypassed the race for raw intelligence benchmarks to compete entirely on operational trust, uncertainty recognition, and long-horizon reliability. This animated graph illustrates the confidence versus accuracy problem in early systems. They maintain 100% confidence over time, even as execution accuracy degrades sharply. Lacking self-awareness to pause at logic gaps, the system drives a failing workflow until the entire chain collapses. Opus 4.8 attacks this by introducing native uncertainty tracking and honesty benchmarks. It continuously monitors its own context retention, accurately gauging when its evidence is too thin to proceed. It pairs this with adaptive reasoning. Instead of applying maximum compute power indiscriminately to every operation, the model dynamically allocates deep compute only to the specific steps that require complex, verified thinking. The practical result is a system that behaves like a disciplined engineer. Instead of barreling forward with incomplete data, the model actively pauses the workflow, flags its uncertainty, and challenges flawed assumptions before they compound. Equipping AI to pause and verify its own logic is the non-negotiable base layer required before assigning it to mission-critical infrastructure. This diagram illustrates the monolithic agent bottleneck. When a single AI model processes a massive task, it sequences every piece of data through one central point. As the tasks drag on, context drift sets in, latency compounds, and the workflow collapses under its own weight. The solution to this bottleneck is dynamic workflow orchestration. We see this implemented directly in Claude Code's recent architectural update. Instead of doing everything itself, the system uses a router agent. This router breaks the massive task into components, spawning specialized subagents to handle pieces in parallel. These subagents execute independently, gathering data, writing code, running tests, operating simultaneously before cleanly aggregating their verified results. This parallelization enforces strict context isolation. Because each subagent only sees the specific parameters required for its task, the broader system avoids the confusion of competing, overlapping data streams. Enterprise AI software architecture has abandoned linear conversational interfaces. It relies entirely on distributed, autonomous operational teams working in concert. This multi-agent architecture scales far beyond software engineering. It is currently industrializing creative workflows, as seen in digital marketing platforms like Ads Creator AI. Here is the Ads Creator AI workflow cycle. In steps 1 and 2, the system autonomously coordinates ad copy generation alongside visual design, executing simultaneously. Steps 3, 4, and 5 reveal a continuous execution loop, developing variations, producing assets, and optimizing performance continuously, removing human production bottlenecks. We see this exact multimodal orchestration driving real-time global communications through systems like 11 Labs' Dubbing Studio V2. Early AI translation pipelines had a severe flaw. They successfully converted words from one language to another, but they destroyed the emotional context, the conversational pacing, and the unique identity of the speaker. Dubbing V2 corrects this by treating voice as a highly complex behavioral layer, preserving the original emotional continuity and timing across multiple languages simultaneously. This establishes voice and synthetic audio as a programmable interface layer, fully integrated into global enterprise communication infrastructure. Digital media production no longer relies on scattered human teams operating isolated creative tools. It operates as a continuously generated, dynamically coordinated multimodal pipeline. But this leverage introduces a harsh economic reality. Executing parallel long-horizon workflows requires massive amounts of compounding compute power. We saw this tension surface during the developer backlash over GitHub Copilot's shift to token-based billing. Agentic engineering consumes dense computational resources. It cannot be priced or managed like a lightweight SaaS subscription. Enterprise purchasing behavior reflects this constraint. Platforms like Glean recently crossed $300 million in revenue because their AI retrieval systems function as pure cost reduction infrastructure. This scatter plot maps compute cost against operational ROI. Enterprises will only cross the adoption threshold and pay for high compute autonomous tools if those systems prove a strict, measurable financial return. Alongside economic limits, organizations face systemic internal risks. A growing phenomenon is the AI-pilled enterprise, companies deploying AI aggressively without an equivalent investment in governance. These organizations confuse basic automation with strategic transformation. They prematurely remove human review layers, treating AI outputs as inherently authoritative and leaving their operations completely exposed to unmonitored failures. At the user level, deploying highly persuasive, persistent conversational agents introduces psychological risk. The emerging clinical debate over AI psychosis highlights the danger of models generating deep emotional dependency in vulnerable users. Resolving this requires mandatory, system-level solutions. Infrastructure must include strict behavioral safeguards, long-session interaction monitoring, and continuous runtime oversight. Furthermore, human escalation frameworks must be embedded directly into the architecture, giving human supervisors the immediate capability to flag and manually interrupt rogue automated workflows. Unmanaged adoption of agentic AI trades operational leverage for systemic fragility. The defining realization of the 2026 AI landscape is clear. The competitive frontier has permanently shifted from intelligence to execution quality. The new enterprise AI stack begins with a reliability base layer to prevent hallucination. On top is the orchestration layer for dynamic multi-agent coordination. Next, the multimodal layer autonomously spans code, audio, and visuals. Finally, the governance layer ensures human oversight and measurable ROI. Enterprise leaders must build toward this specific stack, prioritizing rigorous operational maturity over the novelty of testing the latest frontier model. Long-term competitive advantage belongs to the organizations that prioritize disciplined, reliable operational foundations over the scale of the models they deploy.